Hello there, experimenters. Dr. Rob here with some liquid glass science, all thanks to Inspiring Australia Queensland, who proudly present the Science Week Queensland program, Glass, more than meets the eye. So what is this liquid glass science of which I speak? Well, it's actually a little bit of chemistry that I've done a lot of times, more than I can count, in fact. It is making a type of slime, my favourite type of slime, in fact, and it resembles liquid glass. So what do you need to make this slime? Not very much, in fact. You do need some clear glue and you'll need some borax as well. Those are the main two ingredients. Right, let's start with the clear glue. You need to use, well, it doesn't really matter exactly how much of this you use. You can experiment around a little bit, but however much clear glue you use, that'll do for this batch. You want about twice as much water, so 2 times the amount of water that you use as your glue. So we're up to about there. It's fairly approximate. So I'm just going to eyeball this one. There. I think that's tripled the total amount of liquid. I'm going to give that a bit of a stir to mix it all about. Now, while I'm mixing that around, let me tell you a little bit about this glue that we're using. It's an interesting kind of a glue. It actually contains a polymer, which is a fancy science word for plastic. And the type of plastic inside this glue is something called polyvinyl alcohol, or PVA for short. Now there's a couple of different types of PVA. You might have struck the PVA glue that's white. Well, this is PVA glue that's clear, and the PVAs are actually slightly different. So this particular PVA is a soluble type of plastic. It's a plastic that actually dissolves in water, which is a bit weird, and that's exactly what we have here. Plastic dissolved in water with a bit more water added, and it just kind of gives you this very thin liquid. Oh, now a place you might have seen PVA as a plastic as opposed to a glue is one of these little numbers, these little dishwasher pouches. The plastic that these are all wrapped in is PVA, which is why when they go into the dishwasher, they dissolve. Clever, huh? Anyway, back to the slime. Once you've mixed the water and the glue around, great, done, you need the last ingredient, which is the borax. Now I've mixed the borax, which is a powder, with a bit of water, about a teaspoon of borax in water, give it a good mix around, and then we're gonna add that very slowly. If you want your slime to be anything other than clear, you wanna add some food color or some glitter, now's the time to do it before the borax goes in. I'm gonna keep this one clear so it does look like, well, liquid glass. All right, so you wanna tip slowly and stir at the same time. And what you'll see is those polymer molecules, those plastic molecules, start to all link together. Instead of floating around in the liquid, all nice and fancy free, they start to, you can see it happening already, they start to gum up and turn into a slime. In scientific terms, this is known as cross-linking, because all of those long strands of plastic molecules are now starting to get joined up to each other. And they are making, oh, look at that, they are making our slime. I'm gonna add a little bit more to that last lot of liquid down the bottom. And I think that will be enough. Oh, spilling some on the desk here as well. Alrighty, excellent. Now, we don't want to just make slime, of course. We're going to do some testing with our slime too, but let's get that all in there. Now, why do I call this liquid glass slime? Well, I think it's kind of obvious in a way. It's clear, and it's sort of, well, it looks like a solid, but it looks like a liquid, and that's the great thing about slime. It's somewhere between a solid and a liquid, I suppose. It's basically a very thick liquid, or a very viscous liquid. And you can see just as I hold it there, it's starting to drip down very slowly. And in fact, glass, when they make it, it starts off as a liquid. And the molten glass, or the liquid glass, is poured out until it's super flat, and then it's set or cooled into the shape of a window. In order to do that, in fact, they pour it out onto a bed of liquid tin. So molten tin with molten glass on top, it cools slowly and you get a window out of that. Pretty cool. Now, we can do some tests with our slime if we'd like to, and I've got some other slime down here too. Oh, some blue slime that I made earlier. Snap-lock bags are great for keeping your slime in because they keep them nice and wet. If you leave the slime out, eventually it dries out and goes all crispy. So, what tests are we going to do with the slime? I had a couple of tests, and they both test the viscosity, that's the thickness or the runniness of the slime. Part of science is called rheology. Here's another big word for you. It's how things flow. Right, test number one, you'll need a funnel. It can be a funnel like this or one that I've made from a soft drink bottle. If you use a kitchen funnel, it's going to have to be well washed before it goes back into the kitchen. Alrighty, so funnel and something to run the slime into. There we go, we've got our beaker there. And we'll put the funnel in the beaker like that, and let's load the slime in there. And what we're going to measure is how long it takes the slime to run through the beaker. If I can get it off the spoon. What you'll notice is a little bit of liquid goes through straight away. That wasn't really slimed up liquid. But the rest of that slime will very slowly start to creep. Oh, it's starting to go through now. It'll start to creep through that funnel. So you can get a stopwatch and you can measure the flow rate of the slime. So if you make several batches of slime, you can measure how viscous each one is. Another test you can do, it also tests the flow rate or the viscosity. You can get glass, you can get a little ramp like this, and you can measure how quickly your slime flows down a ramp. Oh, let's just get a chunk of blue slime out here. I've got glitter in this blue slime, so it looks extra great. Look at that. Put a chunk of slime at the top of the ramp, like so, and let it go. And again, you would time how long it takes to ooze or slime all the way down the ramp. And you can see it's probably going to reach there in about 30 or 40 seconds. It'll get all the way to the bottom. So that's another measure of viscosity or flow rate. Let's check back on this one here. Oh, it's starting to reach the bottom. So we're starting to get it come out. So I reckon it's probably going to take 5 to 10 minutes for that slime to go all the way through. So if you make different batches of slime, which is what a good scientist does, and they change their variables, you can measure the viscosity of each one and you can keep your notes. Look, just have fun with it. And when you're done, of course, wash your hands. You don't want to take this back inside the house. Happy experimenting.